Hello, my name is Jan. I'm a student at Gimnazija Kranj and I'm here to present to you the project of our famous Slovenian mathematician. His name was Jurij Vega. Jurij Vega was born in 1754 in Zagorice near Ljubljana. He first received education by a local priest, and when he was 13 years old, he moved to Ljubljana. He attended a Jesuitical high school there, where he received a quite decent education of natural sciences and mathematics, because Jesuits were really into that. Now, in those times, it was quite difficult for people to pay high school education, and that was something only rich people could really afford. But his family managed to pay. After finishing his high school, Jurij Vega attended a lyceum in Ljubljana, where he studied philosophy for 2 more years. His first official job was a nautical engineer, and he dealt with regulational areas of Sava and Ljubljanica rivers. Now, Vega was quite interested in military service, so in 1781 he moved to Vienna, where he became a mathematical professor at the artillery school. At that time, he already strived for the introduction of metric system, but unfortunately his wishes were not very well heard. Now, the metric system was later introduced by the Emperor Franz Joseph I in year 1871. While still working as a soldier, he managed to publish 17 mathematical, physical, and astronomical books. They were printed many times, and that made him quite famous even outside Austrian borders. Due to an excellent combination of his professional military abilities, teaching skills, and incredible inventiveness, he would quickly rise through the ranks from an enlisted man to second lieutenant, and then to, at the end, lieutenant colonel. And I may say that's a quite high rank for a Slovenian-born soldier. In 1793, he returned to Vienna to teach mathematics, but he was soon recalled to active battlefield duty. He used his mathematical and physical abilities to construct mortar barrels which were longer and stronger, and that would improve range of shelling greatly. Jurij Vega received many achievements in his life. In 1794, he became an associate member of British Scientific Society. In 1797, he became a member of Academy of Practical Sciences in Maine, and in his most successful year, for that matter, in 1798, he became member of Physical and Mathematical Society of Erfurt, the Bohemian Scientific Society, and Prussian Academy of Sciences in Berlin. Now, he was awarded the Order of Maria Theresa, and on the 22nd of August in 1800, he obtained a title of hereditary baron, and that included right to bear his own coat of arms. Jurij Vega started publishing his mathematical works while still working as a soldier, when he realized there were not many good mathematical books. He wrote a textbook called Vorlesungen über die Mathematik, which in English means lectures about mathematics. Now, the textbook included, but was not limited, to logic, algebra, geometry, geodesy, geometry of curves, ballistics, and special physics. Some of his other quite interesting disquisitions are about finding new aspect on gravity law of gravitation, disquisition on mass determination and distance between celestial bodies, disquisition about new French measures and weights, and disquisitions about pi. Now, his famous logarithm tables. Vega published a series of books of logarithm tables, and for the purpose of more accurate and faster calculation of logarithms, he even developed his own equation. He decided to publish 3 types of books of logarithm tables, which would be used for 3 different purposes. For the purpose of education, for everyday use, and for more exacting and important calculations. Now, his famous Vega's logarithms were reprinted more than 300 times and were translated into 10 world languages. Many students and scientists even used them until electronic computers were invented. The logarithm tables are probably one of the biggest scientific contributions of Slovenia to science. His logarithm tables were used by students, engineers, and also scientists for more than 200 years. Now, Vega published 4 logarithm manuals. The most important one is used for the most exacting and accurate calculations, and it is called Treasury of All Algorithms. Vega greatly improved Mercator's equation and developed a special equation named Vegova vrstica. Vega's work greatly contributed to a scientific and industrial revolution of the 19th century here in Europe. He's quite famous here in Slovenia too. He was on our stamp and on our $50 banknote. And now for the end, I have prepared some interesting facts about him. There is a crater on the moon named after him. There's an asteroid called 14966 Jurij Vega, and we even have high school named after him called Jurij Vega's Technical High School. So this is everything about his life. And now my schoolmate Ursha will present to you the usage of slide rule. The slide rule. The slide rule is a mechanical analog computer that is used for multiplication, division, logarithms, trigonometry, and also, but rarely, for addition and subtraction. We will present to you multiplication and division using simple calculations. Multiplication. If we want to multiplicate with the slide rule, for example 2 times 3, we set the middle scale, the green one, with its beginning, number 1, to the place where the upper C scale shows number 2. Now we have to move the cursor, which is a see-through ruler, on the place to cover 2 and 1 and at the same time. This is the initial position for our own calculation. We said that we want to calculate 2 times 3, so we have to move the cursor to 3 on the green scale and read the number just above number 3 on C scale. It's 6. Division. It's quite similar procedure to multiplication. We just switch the order of computation. For example, if we want to divide 6 and 3, we have to set the middle scale that shows 3. just under the number 6 on the upper scale C. We move the cursor to number 1 on the middle scale and read the result on C scale. The number that is above the one on green scale is 2. Perhaps you remember the position when we calculated 2 times 3 and 6 divided by 3. The position of the scales is the same, which is quite logical because we operated with the same numbers. The slide rule is not in use anymore for about 50 years or so. It has been replaced by electronic calculators, which are easier to use, produce, and they are faster to use. But if you're fond of mathematical accessories, especially old ones, I believe slide rule would be quite interesting for you to learn about it. The slide rule rules.